Hello everyone, and welcome back to the show. It's your host, Ichino-ani. Today is August 4th, a wonderful Monday. And I have a super interesting article from the archives for us to explore together. It's from the world of machine learning, hierarchy. Oh, the title is Benchmarking Bound Generalization via Synthetic Attribute Substitutions. That's a mouthful, isn't it? And the curl is chaps://arxiv.org/EBS/2507.23784. It's long, but don't worry, everyone. They're going to break it down, just like we're in class. So let's start with the big question. What problem is this paper trying to solve? Imagine you have a super smart AI, and you want to know how it's making its decisions. This is really important. Especially if the AI is helping doctors or driving cars. There's a special type of AI called a Concept Bottleneck Model, Think of it like a student who has to show their work. To identify a blue jay, for example, it first has to say, "Okay, I see a blue crown, and I see blue wings." And based on those steps, it concludes it must be a blue jay. This makes us trust the AI more, right? Here's the tricky part the researchers found. These AIs can sometimes be a little sneaky. They found that if you show this AI a picture of a blue jay, you use a computer to change its blue crown to a yellow one. AI still says, "I see a blue crown." Oh, that's a big problem. It means the AI isn't really clicking at the crown. It just memorized that the word blue jay usually goes with the words blue crown. It's like it memorized the answer key without understanding the question. This makes the AI not very reliable, does it? So the brilliant people behind this paper came up with a plan to test these AIs properly. They created their own special set of pictures called the sub-dataset. It's full of computer-generated bird pictures with swapped features, like a blue jay with a yellow crown, or a cardinal with the long, thin beak of a hummingbird. And making these pictures was a challenge all on its own. You can't just tell an image generator, make a blue jay with a yellow crown. The paper shows that often, the AI just ignores you and makes a regular blue jay. So they invented a new method called Diffusion Guidance. It's a bit like a buddy system for creating images. The AI is told to make two images at the same time. One prompt is the hard one, like, make a photo of a blue jay with a yellow crown. The other prompt is the easy one, like, make a photo of any brand with a yellow crown. By generating them together, the easy task helps guide the hard task. It helps the AI correctly put the yellow crown on the blue jay, while keeping everything else looking like a blue jay. Isn't that a clever way to do it? Now, you might be thinking, okay, I know canny, birds are nice, but how does this help us in our daily lives? That is an excellent question. Let's look at some examples. First, let's think about medicine. Imagine an AI that helps doctors spot skin cancer. A good, trustworthy AI would say, "I think this might be a problem because its border is irregular, and its shape is not symmetrical." It's explaining its reasoning using concepts doctors understand. Or what if the AI is cheating with the one with the birds? It might have just memorized that dog. Splotchy things are often bad, without actually checking the shape of the border. This could lead to a very dangerous mistake. By using this paper's method, we can create fake medical images to test the AI. We could make an image of a knoll that has a perfectly normal border, but other strange features. This makes sure the AI is really checking all the concepts, making it a safer and more reliable helper for our doctors. Okay, second example. Let's think about self-driving cars. Super important, right? A self-driving car needs to recognize a stop sign. For now, would break it down. I see a red color, an octagon shape, and the letters S-T-O-P. But what if it's a foggy day and the sign is a bit faded? Or what if a tree branch is covering one of the letters? AI that just memorized made octagon equals stop might get confused and fail to stop the car. What would be so dangerous? So with the ideas from this paper, we can create a test data set of weird stop signs. A stop sign that looks a little bit purple, or one that's covered in graffiti. By testing the car's AI on these tricky images, we can build a system that is much more robust and safe for everyone on the road. And for our third example, let's talk about something we all use, recommendation systems. We know when a website suggests a movie or a product, an AI might say, or I'm recommending this shirt because you like boobs. things when you like striped patterns? Or what if it just memorized that you once bought a blue striped shirt? It might get stuck and only ever recommend blue striped things. It doesn't understand that blue and then striped are two separate ideas. You might like a red striped shirt or a solid blue shirt. This research helps us test if the AI truly understands these separate concepts. This leads to better, more helpful recommendations that don't just show you the same thing over and over. Now, how does this compare to other technologies? Well, the researchers showed that the TIB method for making images is much better than just giving a simple command to a normal image generator. Our method gives them precise control, which is needed to create these perfect test images. And you know what's really interesting? We also tested other big, powerful AI models called VOMs, like Clip. And they found that even these huge models have the same problem. They also tend to hallucinate or see the original features of a bird, even when they've been changed. For example, they'd still see a blue crown on our yellow, round blue jay. This shows that this is a really big and widespread challenge in AI. So to wrap things up, everyone, this paper teaches us a very important lesson. Even when an AI seems to be explaining itself, it might be cheating by memorizing instead of truly understanding. But thanks to the new sub dataset and the clever touch method, we now have better tools to test our eyes. It's like a teacher making a really good exam to find out which students truly get it. This work helps us move closer to building AI systems that are not only smart, but also honest and trustworthy. And that's a future we can all be excited about. That's all the time we have for today. Thank you for tuning in. This was your host, ichino-ani. I'll see you next time. Bye-bye.